The circular economy is an area of research that significantly influences business and policy. To achieve a circular economy, we need to build on the scientific ideas that brought it about. In this video, we summarize a white paper about 10 insights for the circular economy, drawn from the scientific field of industrial ecology. Insight 1. Nature offers a model for industry. Industrial ecology draws an analogy between industrial activity and the natural cycles of materials and energy, which are a model for a circular economy. For example, in nature, the nutrients from decaying biomass are used by other organisms to grow, together forming complex food webs. This approach is mimicked in industrial symbiosis, in which industries exchange waste as a resource. For instance, waste from a power plant could be a raw material for a cement factory. Insight 2. Societies metabolize like organisms. Industrial ecologists judge a society by its metabolism, the materials and energy it consumes, the activities this enables, and the resulting waste and emissions. They use material flow analysis to study socioeconomic metabolism, the stocks and flows of energy and materials in our lives. Examples of material flows include the food you consume and the packaging you use and discard. Material stocks include the vast amounts of bricks, concrete, glass, and steel that make up the buildings where we live and work. Insight 3. We cannot do without the environment. Whether linear or circular, the economy needs the natural environment, which provides essential resources such as food and materials, and assimilates waste. Industrial ecology has been defined as the means by which humanity can deliberately and rationally approach a desirable carrying capacity. It is a field of research that identifies ways of doing things that helps us stay within the environmental limits of ecosystems. The point is not to become independent of nature because we can't, but to work with nature wisely. Insight 4. Environmental impacts are inevitable. Because of its dependence on nature, a circular economy cannot avoid environmental impacts altogether, but it can target and reduce many such impacts, and create strategies to live better and harm the environment less. A fully circular system is physically impossible because the use of materials always requires energy and generates some waste that is unavoidable. The end goal is not to create a perfect circle, but to minimize waste and environmental impacts. Insight 5. A life cycle perspective avoids burden shifting. Industrial ecology looks at human activity from a life cycle perspective. It considers all impacts from raw material extraction to end-of-life waste to ensure that we don't reduce one impact but accidentally increase another. For example, a more energy-efficient building may require building materials that are energy-intensive to manufacture, partly offsetting the energy savings during the use of the building. Such a transfer of impacts is called burden shifting and can only be avoided by considering the whole life cycle. Insight 6. Early systemic intervention prevents waste. Waste happens when material ends up in a place where it has no use. A good example is food waste, where prevention of waste, rather than its recovery, leads to the largest reduction in greenhouse gas emissions. Almost any strategy for impact reduction requires a systemic approach that includes many activities across the entire life cycle. For example, waste prevention requires better product design, take-back infrastructure, facilities and technologies for repair and disassembly, as well as new business models and government regulations. Insight 7. Location shapes environmental impacts. The environmental impacts of human activity depend on where the activity takes place, which means the circular economy must be adapted to its location. For example, studies in industrial ecology show that food and electricity production have different impacts in different countries. Often, the burden is shifted from high-income countries which purchase many goods to low-income countries that manufacture the goods. Insight 8. Material use depends on infrastructure. Infrastructure, such as buildings and energy and transport networks, requires vast amounts of material to construct and maintain. Infrastructure also locks society into long-term patterns of material and energy use. For example, a road that is built now will require materials for maintenance far into the future and may lead to more car use, which in turn requires lots of materials and energy. Insight 9. Technology is not a panacea. Technology can bring positive change, but a circular economy also needs changes in behavior, business models, and government policy. Industrial ecology shows that population, wealth, and technology are the driving forces of environmental impact. More people with more to spend tend to pollute more unless they make different choices regarding the products and services they use. For example, we can reduce our impact through more efficient food production technology, but also by changing our diets. Insight 10. The future is unknown, but may be anticipated. Not even industrial ecology can predict the future, but sometimes you have to take an educated guess. With our forward-looking assessment methods, industrial ecology helps anticipate the environmental benefits of new technologies and practices. Understanding the future impacts of innovative products, services, and technologies is critical to supporting the circular economy. To learn more about the field of industrial ecology and what it means for the circular economy, read the full white paper. It is available from is4ie.org/whitepaper.